So as you can see from the title, I decided to provide in this talk some reflections and a discussion of open challenges in fuzzing, in different forms of fuzzing, whitebox fuzzing, greybox fuzzing, blackbox fuzzing. I worked with most of them over the years. In fact, we're preparing this. By the way, I'm wondering if you can
get the mouse pointer and go to the top of the thing. Because normally.
Because I don't see it on my screen.
Yeah, and then if you minimize it.
All right.
Yeah, I'll move it somewhere.
All right. Okay, so we start again. So I was saying that in this talk I'm going to provide some reflections and also mention some open challenges that I see in fuzzing, in all forms of fuzzing, including whitebox, greybox, and blackbox fuzzing. In fact, when I started to prepare for this talk, I was trying to remember what was my first fuzzing paper, and it was this one from almost 20 years ago. So as you can see, this was saying that we're using a combination of symbolic and concrete executions. So this is what has become dynamic symbolic execution, also known by many other names. In fact, in this talk, I'm going to refer to it as whitebox fuzzing. So over the years, I continue to work on whitebox fuzzing. And as you can see, our ambition these days is to run whitebox fuzzing forever. I've also done some work on greybox fuzzing. So for instance, at the last ISTA, we had this paper on high throughput fuzzing of network applications, and also on blackbox fuzzing. In fact, this afternoon, my colleague Ellie will present this paper on grammar mutation for testing input parser. Unfortunately, our student Bashir could not be here due to a visa issue. Now, I think you agree with me that these colors of fuzzing are a bit boring, and fuzzing deserves much more. So that's why I have here like a rainbow of colors for in honor of fuzzing. Now, I think overall, fuzzing is definitely doing very well. And
just sorry for it. So from the Zoom, it still shows your first page, so they cannot see your PPT.
Okay, so what should I do?
Maybe you have to change which screen you are sharing or something like that.
I think it might be best if you're willing to share your entire screen. I seem to recall that can be some problem.
Yeah, but then I think it's going to show in presenter mode, which is also not ideal. I mean, I'm not sure how to.
You can play into a window, play the slides into
You can see, I mean, this is not red.
This is good.
Oh, this works, yeah.
Yeah, but do you see it on
Yep.
Zoom?
Yep.
You see this?
Yep.
Okay, I'm pleasantly surprised. Okay, sorry. Let's again. All right. We are here. All right. So I think that as a whole, I think that fuzzing is doing extremely well. I mean, there are many successes out there. So if we look at whitebox fuzzing, I'm going to use the example, our tool Clee, which was also mentioned by Lajlo. It's really great to see it being used by so many different groups in both academia and industry. As another example, I think most people here know about Sage from Microsoft, which is credited with finding 1/3 of the fuzzing bugs during the development of Windows 7. In terms of greybox fuzzing, I think I'm mentioning here two examples. AFL, which I think everybody knows it. It's been a revolutionary greybox fuzzer with a long list of trophies. And again, it has enabled a lot of interesting work in this space. And I'm also mentioning here Google's OSS Fuzz, which is, again, I'm sure everybody here is familiar with it. It's a fuzzing platform for open source software. And to date, it has found more than 8,000 vulnerabilities and 28,000 bugs in hundreds of open source software. Blackbox fuzzing has been extremely successful as well in particular domains, influential domains. I'm mentioning here two of them. So in terms of compiler fuzzing, we have fuzzers like CSmith and EMI. They discovered hundreds of bugs in mature compilers like GCC and Clang. And as another example, SQL Lancer, which is a fuzzer for database management systems. Again, it has found hundreds of bugs in popular database management systems like SQLite and Postgres SQL. So I think that in some ways, we reached a point where the question is not whether fuzzing finds bugs, but I think there is a concern to me why fuzzing keeps fuzzing bugs in released software, what would it take to actually try to stop these bugs in their tracks, right? And I think perhaps like to partly answer this question, I thought it would be interesting to look at how software evolves over time, how testing of software in particular evolves over time. So almost 10 years ago, we had in ISTA 2014, we had this paper of RIG, where we look at the evolution of testing in 6 popular open source applications. And we analyzed 250 revisions per application. And the conclusion there was that actually a lot of code is added or modified without being tested. So almost a decade later, I thought it would be interesting to try to see if things have changed. And I was very lucky to have talented MH student at Imperial College working for his final project on this question. So trying to replicate this and extend these results. So what we decided to do here was actually to take the same 6 applications. So we added 3 more to that. And instead of looking at 250 revisions, we look at 2,500 revisions, so a factor of 10x. And because of different development styles and other reasons, we ended up looking at these time frames that you can see here.
So, but if you click on those 3 dots above more, you can hide that thing. And see the right hand side of the top thing, there's 3 dots. You should be able to then do high floating control. Yeah, that's it.
Right. Yeah, not not the easiest to also connect to Zoom, but I think we managed to make it work. All right. So as you can see, these applications, I'm sure that most of you have heard of them. Like we have things like APR, BUtils, curl, Git, Lite2, Memcached, Redis, Vim, ZeroMQ. So these are widely used applications in industry. And with lots of different users. So I mentioned here, we have between 3 and 14 years of development time per project. And because many of these code revisions do not deal with code change, many of these revisions do not change code, we ended up with between 200 and 1900 code revisions per project. All right, so what observations have we made? So I think you might not find it surprising that code keeps increases over time. All right. I mean, I think there is like a big concern here in terms of like software bloat, but I won't have time to get into this today. But yes, we see increases in this project between 2.5 and 33,000 lines of code. So in percentages, we this code increases between 24% and 268% in this time frame. Now, if we look actually at the developer test suites and we try to measure like the coverage that they achieve in the code, I think the good news is that overall, you can see like these lines are pretty much flat, or we see slight increases. And in general, we see like small increases, like, by 2.8 percentage point here, 3.7 percentage point here, and so on. But we see some bigger ones as well, particularly in Vim. We see the highest increase with 22.7 percentage points. And actually, if you do look at Vim, you're going to see that in this time period, developers have started to pay a lot of attention to testing, and they put like a lot of effort in improving the testing on Vim. I think this paid off, at least in terms of overall coverage. However, we do have also like a decrease in coverage. We see Redis here with quite a substantial decrease, 9.2 percentage points. And I think Redis was one of the ones where we had they added like 22,000 lines of code, and I think they haven't managed to keep up with the testing. Now, more than overall coverage, right? So here's a graph that actually shows you the patch coverage for these projects in this development time. So by patch coverage, I mean the percentage of lines in the patch which are tested by the developer test suite. So first of all, note that this is really a necessary, I mean, this should be like a necessary thing to do with the patch, but it's by no means sufficient, right? I mean, in fact, a lot of patch coverage, it's incidental, right? So you just happen to have a test case, but you're not really testing the patch. So I'm going to get into that a bit later again. So here, as you can see, we group these patches in terms of like percentage coverage. So we have like in dark red here, we have patches where absolutely no line of code is touched by the developer test suite. And in dark green, we see cases where 100% of the lines are touched. And I think that the worrying thing is how much red there is here, right? So we are talking about code that is added or modified without even a single test case executing that code, right? And it's quite bad, I would say. At the same time, if I do put my developer's hat on, I do know how difficult it is, to have high patch coverage in many cases. And, I know that many of my patches do not achieve that either. By the way, in case you are the optimist and you see like, well, but it's actually great to have so many patches which, have like 100% coverage. This actually, it's, does not show like the size of these patches, and, the small patches of 1 or 2 lines of code tend to have like, are more likely to have like full coverage than, a patch which has like 1,000 lines of code. All right, so my question is, could fuzzers help change the situation, right? Could we have, for instance, have developers write better test suites, okay? And I think my answer is yes, but, okay, but we're not there. So why aren't we there yet? So I think, first of all, we do have to admit that we're not agile enough. So most of our techniques work on whole program testing, and having done both, I know for sure that it's much easier to do whole program testing, but it's, and perhaps it's like the natural point to start, but I think we should, I'd like to see more and more focus on patch testing, if you want. Like, most of our benchmark suites are also measured global metrics, right? So we look at overall bugs found in the code, we look at overall coverage, and I actually do think that we've had like a lot of good progress on patch testing techniques, but I think the results are still poor overall compared to like, this overall testing techniques. So the ideal thing, of course, like, it's whenever like a patch would be pushed into a project, you have like this amazing system that finds any bugs that are introduced in the patch, gets full patch coverage, and actually tests the patch meaningfully. So what we'd like to have here is, if a patch changes behavior, you'd like to have a test that shows the change in behavior. So pre-patch, the program is doing one thing, post-patch is doing something else. Otherwise, as I said, you might just get like incidental coverage, which is not that useful. So I think that's a moment to give a shout out to CI Fuzz. So that's a CI version of OSS Fuzz where it runs for 10 minutes per patch. And it's going to run only the fuzzers that reach the change files in previous iterations. So I think this is, for instance, like the dashboard that CI Fuzz has. The authors tell me that it was active only for a limited time. So you can see we have like around like 100,000 runs, and it found 1,600 bugs. Although if you do look deeper into these results, they seem to be dominated by this Grok application which reports over 1,000 crashes. And I think, as far as I understand, these are not unique crashes in the case of OSS Fuzz. These are just basically crashes that was observed, which could have like, many duplicates. So I think that's a great initiative, but really I would love to see, similar reporting on CI Fuzz, similar, list of trophies, and most importantly, community attention, as for OSS Fuzz, all right? Okay, another, of course, limitation that we have, and this is like a big challenge, is that, we're not fast enough. And if you look at most of these fuzzing campaigns, you're expected, as you know, with the fuzzing guidelines and so on, to run for 24 hours, right? Or in the case of OSS Fuzz, 23 for some strange technical reasons. And I think that's definitely not fast enough for patch testing. So I think there are two different directions, of course, in which we could go to do better. And I think the community is exploring both of these directions. So one of them is targeted exploration, of course. I mentioned here two examples. So one from whitebox, so our work on the catch, and the other one in the greybox fuzzing domain, the work on FLGo from Marcel here and his authors, which I think that both of these papers, I think, which both have like, I think they're a decade old almost right now, have shown like a lot of promise, and that, targeted exploration can, of course, work, and it would be wonderful to see like more deployments of these techniques. The other direction, of course, is to reuse previous analysis results, right? So in case you wonder, this is what this running symbolic execution forever is meant to do. In the context of whitebox fuzzing, it's particularly important to reuse existing results because some of them are constraint solving queries, which can be quite expensive. And the other example, is the one that I mentioned for CI fuzz, where, which only runs the fuzzers that reach the changed files. And I think this can be improved to work at the finer level of granularity. Okay, so another challenge is that these techniques are not automated enough. And it might be surprising to say that, because whenever you say fuzzing, you say it's a fully automated technique, just generate random inputs. Well, if we look, for instance, at the 9 applications that I mentioned before, which I think you do agree these are widely used, well-known applications, only 3 of them are integrated into OSS Fuzz, all right? And in fact, if you look into the coverage results achieved for the 3 applications, you're going to see that, OSS Fuzz gets around 35% for BUTILS and Lighty, and only 5% for Kerr. So why is that? I mean, if all of us decided to actually spend like, today or this evening to kind of like, put the other 6 applications into OSS Fuzz and perhaps like, improve these numbers overall, would it be just a matter of kind of like, automating things? And the truth is that no. So what's missing here is that you need to write these fuzz targets, all right? And this is manual work. This is manual work. So this is, by the way, in case you wonder what this image represents, when I found it, I thought that, so basically the stormtroopers are all the kind of like the fuzzing work that we're doing in improving algorithms and heuristics. And then they all rely, of course, to run on this little bicycle, right, that you see here. And just to make this point even more strongly, if we look, if we are to count the number of papers on improving fuzzing heuristics, I mean, we're not going to finish anytime soon. It's pretty much like a grain of sand in this desert. But, if we look on papers on test driver generation or fuzz target generation, I mean, I'm not sure if we're going to need the hands of the fingers of 2 hands, or only 1 is going to be enough, right? So I think you see what I'm getting this here. I mean, I think the community should, I think that's one area in which one open challenge that we should put more work into. So let me get back to the question of improving test suites with fuzzing. All right. So despite what I showed you with those 3 applications, I think there are many cases, many applications for which OSS Fuzz, actually, if you look in the dashboard, achieves like amazing results in terms of coverage. All right. And in fact, when I started to work on whitebox fuzzing, so one thing that got me quite excited is that the high coverage that fuzzing can achieve automatically, or semi-automatically, right, in many applications. So this is like the graph that we had in the original, the paper that introduced CLI, showing the coverage, statement coverage achieved in these nucleotide applications like LS, McDur, Echo, Sort, and so on. Right. So you can see like these are fantastic numbers. All right. And in fact, if you compare it to what manual test suites achieve, it is much better, right? And continues to be so. So, you know, this graph essentially shows the difference in percentage points between the coverage achieved by CLI and the coverage achieved by the manual test. So bar going up means that CLI did better, and how many percentage points, and the bar going down means that CLI did worse, and by how many percentage points. So again, I think in terms of coverage, CLI is so much better, right? But I think we all agree that the manual tests do so much more, right? And I think it's always good to have a reminder of the value of test cases, right? Because this is very different from what fuzzers, the inputs that fuzzers generate. So test cases, of course, they have a role in quality assurance. And I think fuzzers, of course, help with that by finding bugs. But there are many other things, right? So fuzzers are very useful as a debugging aid. So if things fail, you know, if you take like a well-written test case, you know, like it's so much easier to debug like the issue, right? Another example is documentation. So whenever I try to understand a large project, for instance, I often start from the test cases for that project. You know, if I try to understand the patch, you know, I start with the test case that demonstrates essentially like what has changed between and after the patch, right? And there are many other examples, right, of how test cases are variable, besides coverage. So essentially, what we'd like from test suites are, of course, high code coverage, but we also like high feature coverage. Okay, and in fact, a good test suite, I think you agree with me, it's a combination, performs a combination of code-based and specification-based testing. And then, of course, there are other things that we want from test suites. We want to be small enough because, again, they're meant for human consumption, and also because we want them to run fast enough, because we don't want to wait like for too long, to run the regression test suite. We want them, again, to be readable. It's, I think, very, very important. And we want them to be well documented. I mean, again, thinking of my personal experience, I've now, as a CLI maintainer, I've started to refuse test cases, or at least like non-trivial test cases, which are not documented, which don't say what they try to do. Because even if they have, they achieve more coverage, or maybe even if they have like some sort of oracle there, if I don't understand exactly what they're testing, that is a problem. We found ourselves kind of looking at these test cases, well, should they really pass or not, right? So I think definitely, we'd like many more from our test suite. Some of them are like, more automatable than others, of course. So one example, one thing that I wanted to advertise was that in recent work, together with Arindam here and Karin and Ellie, we contributed this fuzzer generated test to the LLVM test suite. So 16 out of the 24 got accepted so far. The main challenge, of course, was to add oracles and to minimize these programs. And I won't say more about it because we have like this paper in ISTA which will be presented on Wednesday. So try to be there on Wednesday at 2:30. Arindam will present this work. So in fact, I think this brings me to the last part of my talk, where I want to discuss a bit more oracles and input minimization, which, as I said, were the main ingredients that were needed for this GRACE work on greybox compiler fuzzing to make it able to contribute test cases to LLVM. So oracles, in terms of oracles, the first thing is that manual test cases, that's one of the main reasons for which they are better, because they are typically written with good functional oracles. When we look at fuzzer generating test cases, we have either like generic crash bugs in general software, and this is typically has been the focus of whitebox and greybox fuzzing. And then we also have logical bugs in software for specific domains, right? And this typically has been the focus of blackbox fuzzing. And I think the main challenge here is how do we move beyond the crash oracle. And I think it's clear that, this is actually what developers want. They like more help from fuzzers beyond these crash bugs. So I had this quote here, and I think that, if Manuel would be here, he would certainly blush. It says, one fuzzing researcher of particular note is Manuel Rieger, and I completely agree with that. This is actually from the SQLite webpage, all right? Most fuzzers only look for assertion faults, crashes, undefined behavior, or other easily detected anomalies. Now, I'm not sure if I agree that these are easily detected, but nevertheless, I think you kind of see where developers go with that, all right? Dr. Rieger's fuzzers, on the other hand, are able to find cases where SQLite computes an incorrect answer, right? So that's what they like to find, where the application computes an incorrect answer, not where only if it crashes or not. And I guess, the question here is, the big challenge is, how do we find logical bugs in generating code? What's the sweet spot between, manual work and effectiveness, in particular? So I thought it's a good time to introduce a very recent project, ongoing work that we have in the group. So we wrote this vision paper recently called the page specifications via product programs. So the idea here is to add this. So what's a page specification? A page specification, it's a specification that encodes a property, a cross-page property. All right, so you could write something like this: assert out equals outprev plus 1, where outprev is the value of the variable out in the previous version of the software. All right. So first of all, in order to be able to for this assert to make sense and to be able to be used by a fuzzer, in particular, of course, we need a way to make the state of both versions available to the analyzer. And this is where these product programs come into place. I should mention that, this is joint work with Daniel, who's also here, and Arindam again. And how many of you know about product programs? Daniel and Arindam do, so that's good. So that's a mechanism, really, you can see as a mechanism for merging multiple program versions into a single program. And it's typically used to reason about hyper properties in a security context, particularly non-interference. And in that case, you do like a self-product program, right? You take like the same program and you merge it, you merge it with itself. And this is the paper that introduced it, like this version of product programs that I have in mind. So basically, the questions that we are posing in our ongoing research is, can these product programs, first of all, work for multiple versions of the program, which may be semantically different, of course? Can they be constructed automatically for large programs? So far, this has been constructed for very limited types of programs and programming languages. And can they facilitate the writing of these page specifications? So let me give you a concrete example. That's the easiest thing to understand. So if this is my previous version and this is my current version. So as you see, I changed like z equals x over 4 by z equals x shift left 2. Then the product program simply essentially merges this program and kind of like if you want, like executes the instructions in each program in lockstep. And of course, in order to avoid crashes, we're going to rename all the variables in one program. So let's say like here, like in the previous program version, we just add like this underscore prev. So the product program will be x prev equals y prev minus 1, x equals y minus 1, and then the second instruction as well. All right. So then once we have this, of course, we can write such an assert like z underscore prev, for instance, which may or may not hold it in assumptions here. And yeah, you can use like an off-the-shelf analyzer to reason about this. So let me tell you a little bit about our preliminary experience. So we wrote page spec for several pages from Core Bench. So Core Bench is a collection of complexly or well-programmed pages from popular open source systems. And big thanks here to Marcel and to Abik for assembling this benchmark suite. I think it's a great benchmark suite, which we've used several times in our work. this FL++ and clean should have appeared later in the animation. But basically what we did, we constructed test driver or fuzz targets for the functions involved in these patches. And then we used FL++ and CLE to try to look for violations of patch specifications. All right. So let me give you one example. So that's a patch in LS in this make link name function. So essentially, this make link name function takes like a name of a path to a file, let's say like a/b/f.text, and then it takes the link name, let's say g.text, and it gives you the path to the link name, like a/b/g.text. All right. And the commit that we're looking at the following message: do not hardcode / use this absolute file name and dir name instead. Use stp copy, stp n copy in place of str n copy, str copy. All right. Can you guess what kind of patch this is? What it's supposed to do? I think it's most likely a refactoring, right? I mean, that's and I think our guess was right, as you're going to see shortly. So this is the actual patch. All right. So I won't spend too much time going over it, but yes, as you can see, it's replacing this check. This is what they mean, like do not hardcode /, this check for / with this macro, which does pretty much, the same thing. And then, yeah, it's rewriting this to be a bit simpler instead of this str and str copy, it's using stp copy, and then it's returning the string. So basically what we did, I mean, the one patch spec that we wrote for this was just, certain that the results should be equal. So P and P prev, when you compare them with star.com, they should be the same. We wrote a few other patch specifications, but again, I'm just going to focus on this one for simplicity.
So how is this executed? It's after the return.
Yeah, so basically here, you take this, let's say the developer write this specification, we construct the product program, and then this assert does make sense with the product program in place. And then we just run FL++ and CLE as usual. And, when we do so, both of them actually find a spec violation, which is actually, quite a simple set of inputs for if the name is /a and the nickname is X, the two versions compute different things. Interesting enough, this was indeed a bug that made it into a released version of LS. And a user later on reported it. After it was reported, it was fixed. And right. And I think that, of course, the main takeaway here is that if the developers wrote even such a trivial specification, nothing should change in the result of this function, they would have found, the bug before making it into a release version of LS and affecting users. So after the users reported it, they fixed it. This was actually the fix here in green. So actually what we did, again, we took the original version and the kind of this fixed version, and again checked whether there are any violations of this patch specification. And to our surprise, you're still, FL++ and CLE were both able to find violations. So in particular, if the name is something like /x//y and the nickname is A, there is a difference between the two versions. Now, looking very closely at the function, we believe there is no bug here because essentially, the main difference is between these multiple slashes, which if you look in the POSIX spec, it says that it doesn't matter, if you put one slash or two slashes. But I claim that this is exactly the kind of inputs that we want to add to our regression test suite, together with this patch. This shows a difference between, a behavioral difference introduced by this patch. I mean, perhaps it doesn't matter, but it should be documented so that, others can understand what is going on. And of course, to meaningfully test the patch. So that's what I mean. If you remember in the beginning, I was saying that we should have inputs that trigger divergences when there are divergences.
If this is an example where essentially multiple results are okay, isn't that the kind of thing you don't want to test for? Because you don't want to force the system to have a certain behavior when different alternatives.
But I think you should add this input We don't write assert, but it actually shows, that basically this is also like acceptable, right? So by the way, maybe the following will answer your question. So what we ended up was to write like, we wrote this very change assert, where instead of using stir compare, we use path equivalence. And after, with this page specification, we found no more violations. So this was indeed like the main difference. Yeah. All right. Does this
Yeah.
answer? Okay. So for my last 5 minutes or so, I'm going to discuss again a bit more about oracles and also about input minimization. All right. And let me tell you that. Can you do automated bug finding without input generation? Sounds pretty cool, right?
Static analysis.
Right, not static analysis. Then I guess dynamic analysis. So the answer is yes, and you can actually find bugs in Chrome, in Firefox, in in kind of like important systems if you choose your domain right. Okay, so that's what we did a few years ago to do like this automated bug finding without any input generation. We decided to test PDF readers. All right. So why is it great to test PDF readers? All right, is that there are many PDFs out there. All right. I know that when you read about fuzzing, I think many people are impressed in the beginning when they see like these tutorials like how do you construct like JPEGs out of thin air and yes, I think that's impressive, except that I'm not sure it's for certain classes of bugs you don't need to construct them out of thin air. There are so many JPEGs out there. So that's what we did. We took actually 230,000 PDFs that we found. We fed them to many different readers, including Adobe, the readers in Chrome, in Firefox, Vins. We took like 11 such readers on Linux, and we did like an additional smaller study on Windows with 8 readers. That's the paper that results that discusses our results, and then we wanted to report bugs. Now, here are the kind of bugs that we were able to find. So we looked at 2 kinds of bugs. So the first one was crash bugs. So for instance, here is an example of these PDFs, which is really like a kind of like a text-based document, nothing like very strange about it. It's about Hawaii though, so I'm not sure it displays at all, but this used to crash Chrome. And by the way, by crash, I mean also like generic errors, like in this case, Chrome would say, fail to load the PDF document. And here is a bug in Firefox where basically this is a second kind of bug that we found that, we compared essentially the renderings of different readers. So in this case, this was a correct rendering, and this is what Firefox would display. All right. Both of these bugs are now fixed. But actually, so a few comments. So as I said, like, automated bug finding without any input generation. I mean, in fact, I would say that in this case, these are the best inputs to have if you are interested in looking for bugs, because they are real world, or at least non-security bugs, right? Because these are real world human created documents. So people do expect them to load correctly in any PDF viewer. Now, the challenge was finding the right oracle, right? So in particular, instead for these non-crash bugs, these inconsistencies, we cared about detecting meaningful cross-regional inconsistencies because there are many meaningless ones, as I'm going to mention shortly. And another important challenge was actually we had too many bugs, right? And I think you all know that often this is a question. So 2% of these documents crashed at least one reader, and 13% of them triggered inconsistencies, meaningful inconsistencies, I should say. And the third challenge was that some of these inputs were simply too large. I mean, these are human-created inputs which can have like many pages, many objects. They look quite complex. So if you just send this document to the Chrome or the Firefox, the developer, and say like, look, there is some inconsistency here, like for this like 50-page document, I don't think they're going to take your bug. They're not going to assign it to a very high priority. So our solutions for the PDF domain, I think they were kind of like straightforward. So first of all, we had to ignore inconsistencies which are imperceptible to the human eye. So if you look, for instance, at how Vins and Chromium display like some fonts, I mean, there are like a few pixel differences, but really you're not going to observe them by with the human eye. But if you do a pixel by pixel comparison, you're going to get lots of these inconsistencies, which are really meaningless. So our solution to that was just to read the literature. We found like, this computer vision algorithm, CBAL-WSS-IM, which uses like the human, essentially is inspired by how the, humans view things. And I think it did like a very good job in this case. Later on, I know it was also used by Ali for his work on graphics drivers, also successfully. So yeah, it's quite a nice algorithm that in this case it solved our issues. Dealing with too many errors, in this case, for us it seemed to be enough to do clustering based on the wordings and errors emitted by the readers. Now, I don't know how many false negatives we had, but at least by picking, different representatives from different clusters, we did seem to end up with different bugs most of the time. And in terms of minimizing these documents, we applied, formal delta debugging at the level of PDF objects, right? So the idea is that if this is like, your document, that I believe this is also about in Firefox, but I'm not too sure, as you can see, like this icon is not displayed. Here, the idea is to basically send the documents, ideally a PDF document with a single object, if possible, which is not displayed correctly. Okay, last slide. I think I'm on time. Everybody knows about the bystander effect. So, but the bystander effect comes from social psychology. The idea is that people are less likely to intervene if they witness a crime if there are other people around. All right, and you can also translate this into technology that people actually are more likely to actually do take action if they believe that there are safety mechanisms in place. All right, and I wanted to share like, I think an interesting anecdote about, fuzzing and the bystander effect. So I guess the question here concretely is, I talked a lot about how can we use, whether we can actually use fuzzing to improve developer test suites. And I guess one question is, should developers rely on fuzzers to replace test suites? And I think, if you paid attention to my talk, I guess you know what my answer is to that. So what the anecdote that I wanted to share is that we have this ongoing project with Ahmed and Arindam, and our goal is to actually contribute test cases to various projects. And in this case, we try to contribute a test case to libxml2, which was inspired by the way XML-sec, right, which is a client of libxml2, uses libxml, right? So this was like a way in which we would get like additional coverage in there. So one of the reasons that we were given for not integrating this test case by developers was the following: XML-sec is integrated with OSS fuzz and is continuously fuzzed with the latest libxml2 code from the master branch. So your tests offer very little on top of that. Now the irony was that if you check right now, like for XML-sec, it's kind of like it fails to build right now in OSS fuzz, but I think this is kind of like a secondary issue. I mean, I think that there's some interesting food for thought here in terms of the bystander effect more generally. So with this, that's the end of my talk. So I hope you found some of these reflections and open challenges interesting. I think if we are to summarize perhaps the talk, like the takeaway message is that fuzzing is about finding bugs, but our objective should be to improve software. And I think the key challenge here is how to better integrate fuzzing into the development process. And I talked about various different things, like how do we automatically generate test drivers, they also call fuzz targets, how we use fuzzing in an incremental fashion, generating inputs that trigger different behaviors across versions, using fuzzing to enhance test suites, and moving beyond the crash bugs. Thanks a lot, and very happy to take questions.
Thanks, Christian. This is awesome talk. I was wondering, and you mentioned this in your talk, but I'm thinking that it may be also important to distinguish between different types of patches, especially like in my mind, I can think of you showed examples of patches that were like simple refactoring, where the logic remained the same, but the code changed. You also showed examples of patches where there were like 3 or 4 lines of code change, maybe the behavior changed by a little bit, but it's maybe like a small sort of bug fix. Versus there are like changes which might just add a new feature completely, and that's completely new logic, right? Now, I think a lot of things that you said, I completely agree with you about fuzzing and all the other techniques being useful for the first 2 different categories. I can even take this opportunity to make a shameless plug myself, and on Wednesday in the same session as your paper, we also have a paper using fuzzing for generating regression tests using mutation testing. And I think I'm totally on board with that idea that if you have small changes, you can simply use fuzzing or other technique to generate the test cases, and the test cases for the older version should be good enough to test these small little patches. But when you have changes that are adding new features, completely new pieces of logic, then I don't think anything that we have today can really solve the problem when you have completely new logic that's coming in, right? So I was wondering if you encountered those in all of this work that you're doing, and what your thoughts are on new feature additions.
Yeah, I think that's a very good point, and I do agree with this distinction. And in fact, like I guess you're right implicitly. My message was about these smaller changes that make like relatively small changes in functionality, or perhaps like no changes at all in the case of refactorings. If you add like a huge feature, I mean, I think that perhaps like that should be treated more as a whole program testing in many ways, right? Because yes, I mean, and we've seen patches which they really add like thousands of lines of code, even like if it's like a very large feature. So yeah, I agree with that.
Yeah, thank you for your talk. I'm also interested in the patch testing, and on top of that question, I'm also curious about the correctness and completeness of the patch specification. So specifically, how would you extract these specifications?
Right.
One of you, so you mentioned on one slide, let's say you enroll this by yourself. Are you trying some automatic ways to generate this? Yeah.
No, so this work is simply manual, right? I mean, basically these patches are supposed to be written manually. We did, like, as I said, like our preliminary experience shows that, for many of these smaller patches, are, it's actually quite feasible to write them. And we're not the developers of those, of course, of those systems. So we spend perhaps like a bit more time than they would spend. I think the important thing is that developers, of course, they have the right context, and they are in the right context when they write the patch. They often have like, the imperative version they implemented, and then they have like the declarative version, if you want. There are many cases. I mean, again, I think it's a longer discussion. There are cases in which it's easier to write like a regular specification, right? That should hold like, both in the old version and the new version. But there are plenty of cases when that's actually very tricky to write, and it's much more straightforward to write a specification about what has changed, right? Another thing, yeah, so again, manually written, but also like another important thing is that this patch specification can be partial. So you can specify whatever you think makes sense or is most important or easier to to specify. But of course, like being able to suggest, for instance, specifications automatically, I think that could be like quite interesting. I don't think they can be fully automated, because many of these specifications are about functional properties that only developers know about, right? But definitely you could, I think, that you can actually at least like make suggestions. Yeah.
Let's say if they update the document or they say something in the commit message, okay, let's say we use some NLP technology.
Absolutely. And in fact, like we were, one direction that we want to go is to see, for instance, whether we can write this automatically for refactorings. You say, if the commit message suggests, like the one that I showed you here, is that it's a refactoring, you could try to write these specifications perhaps even automatically. Yes. So good question, good suggestion. Please.
You mentioned these product programs. I'm really curious. It seems like you're coming at it from the perspective of having access to the source code and like actually being the developer. Is there any use case for blackbox testing for these?
No, I mean, I think that in short, these product programs, yes, they are supposed to be done at the source code level. I mean, in principle, I mean, there's nothing to prevent you to do like a product program at the binary level, but I suspect that would be extremely difficult because there may be like many kind of like non-essential changes, if you want, like, due to like compiler optimizations or other cases, right? So I think that would be quite difficult, but maybe for very small patches, you could operate at this level as well. Any?
Product program stuff is very intriguing and a very clean idea. I guess I wonder if it would be viable if you're making a small change really in the guts of a very large application, and maybe the changes would propagate all over the application. Would you have to make a product program for the whole of the big application to take account of that propagation?
Yeah, I mean, I think ideally, yes, you should make a product program of the whole application. In fact, like one thing that we're exploring right now in our research is where you set the boundaries. You know, in some ways, it's similar to some of this reminds me of some of the trade-offs in fuzzing as well, in terms of like what do you instrument, right? Particularly for whitebox fuzzing, execution, but even in greybox fuzzing, right? When you gather coverage instrumentation.
Both like diverges a lot as they get. Like does the notion of product program break down at some point? Suppose that the change, although it is a refactoring, it does actually lead to really quite different functions getting called.
Yes, so absolutely. So I mean, I think that that's a very good remark. So this works best when the control flow does not at least like the sequence of function calls does not diverge significantly, because at some point, yes, I mean, obviously in theory you could make like the product program of you could say like, well, what about making the product program of Apache and of Lighty, right? And yeah, that's not going to work. So I think that you're right. I think that the main the case where things work best is where you kind of like call the same functions. I mean, in fact, if you go into technicalities, I mean, I think we're using like this new version of product programs, which Peter Mueller's group at ETH has developed, where you kind of like do like the function call once. I did it for both versions. Yeah, and I think that's kind of like very important. You can have some small divergences, but once you have very large ones, you run into problems. So very good remark. I didn't have time to get into this level of details in Cornelius?
Two questions actually. One kind of in response to that. Have you thought about it feels like the product program construction, if you were to basically just put those binaries into Andreas Weiss fuzzer, that's not Weiss, it's the other one, the use of likely invariants for fuzzing paper, I don't remember the name, but that would basically, I believe, make Andreas fuzzer just generate invariants that were true for a while before the fuzzer eventually found a way to break them. Like it would basically get you like, here's a bunch of things that seemed like they were true for a while before the fuzzer found.
Yeah, absolutely. I mean, I think that's also like an interesting direction of research. Yeah, good point in kind of using, well, and since we're at UW, right, using like DICON-like systems, right, to infer these invariants at the
I think that's what the paper actually does. It's actually using DICON.
Yes. So yeah, it would be interesting to see what kind of like invariants you get in these product programs. Yes. So good point. We haven't tried anything yet. Yeah. But thanks.
And the other thing would be, instead of using product program, can you just run the program twice, once in the old version, once in the new version in the debugger, and like dump the variables you care about? Like that would not work for the CLI use case, obviously.
But do you mean why would you do that? I guess
well, because that will work for really large programs. So if you like have a substantial change and you actually want to track like how that affects like everything that happens in the program after that.
Perhaps let's discuss
the traces instead of.
Right. Yeah, I mean, I guess it's a different version as well. I mean, it has some disadvantages as well. So one thing, by the way, that we like about these product programs is that once you construct them, of course, all the challenges, yes, you can use them off the shelf.
That's right.
Yes. So.
On one of your slides, you also mentioned the desirable properties of these fuzzer generated tests that they should be readable. I'm not sure if I missed anything in your talk, but have you looked into what can be done to make these tests readable?
Very little, but I can tell you, for instance, we have like this option in CLI that we added at some point. It's called like readable POSIX inputs or something like that. Essentially, what we try to do, like after let's say we find the bug. Okay, so you have like all the constraints that lead to the bug. Now you're trying to add additional constraints that make those inputs to be like ASCII characters, for instance. This makes actually a big difference, huge difference in terms of bug reporting, because if you try, especially in the context of non-security bugs, like once if you try to report something that has like lots of like weird characters, I mean developers, I'm not sure about you, but we got like a lot of bugs rejected, the bug reports rejected saying, yeah, I mean, this doesn't seem like very realistic. And then you follow up and you say, but what about this one? It's the same bug, but it kind of like looks pretty, and developers like it. Because then I think actually I do understand that. I'm also, I've been in the same situation before, right? So yeah, that's as far as we got. But I mean, I think there is much more that we can do. Even simpler things like in the context of compiler testing, right? Like just renaming these variables to have like proper names. Typically, this is something that we're doing kind of like a manual polishing, afterwards. But some of this could be automated. I mean, not everything, but I think that could be something quite interesting to see, like more work in the community on that. Yeah. Or sorry, I think you're first.
Oh, that's enough. Okay. So there are tons of different pathing approaches out there, and I think put all these nice colors on the slide to kind of reflect that. Isn't there still sufficient to only distinguish between whitebox, greybox, and blackbox?
Yeah, I think that's a good question. I would agree with your implication that it's more of a continuum these days. I mean, there are so many different hybrid fuzzers. I mean, and in fact, perhaps like some of the most effective fuzzers right now are hybrid, right? I mean, they use a little bit of whitebox, a little bit of greybox, and also like a little bit of black box in some cases as well. So good point, yes.
So I really like the idea of fuzzing PDF readers, and you talk about one of the challenges is to come up with a good R post to find cross-reader inconsistencies. I wonder, are you using like differential testing or some sort of means?
Yes, exactly. So basically, we display the document, we render it with many different readers, and then we compare it, but not pixel by pixel, as I said. We compare it using this algorithm, and we trigger any divergences. And in general, like, of course, with differential testing, the majority is usually right. It's not always the case. I think we found some cases where it's not the case. And interestingly enough, with PDF readers, Adobe still seems to play like a big role. Like, we had like various developers where we're more impressed by what Adobe did versus like, several other readers. And I think it makes some sense given that PDF comes from Adobe, but yes, in general, yes, differential testing, and we look at the majority, what the majority said is kind of like relevant.
Final question. So I have a very high level question. Do you have any idea in the patch testing in closed source applications?
Again, I mean, I think that the thing that would come to mind is essentially binary level analysis, right? Binary level fuzzing. And in principle, like, these directions that I mentioned in terms of using results or having targeted analysis, I mean, of course, you could apply them on the binary level, only that typically it is more difficult, right? For various technical and perhaps like more fundamental issues as well. So Marcelo, I wanted to ask you, were there any questions online? I didn't look. I wanted to perhaps to involve
there are two questions. So first is you kind of covered that whether product programs are more relevant for highly similar code. Do you want to say?
Sorry, say for high, yes. So I think I covered this. I mean, indeed, like, I think that in general we target that case where the changes are not too big.
Yeah. So the other one is can fuzz driver and fuzz target always be used interchangeably?
So, I mean, I think that this, there's more of a question of terminology, like, especially in fuzzing and testing, as we have like so many names. I mean, with whitebox fuzzing, don't get me started, right? Like dynamic symbolic execution, and concurrent execution, and whitebox fuzzing, and, the list, goes on and on. But I think, with test drivers, I mean, I think that typically in the literature, I think that in general, they're called like test drivers, right? I think that, I believe that Google introduced this name of fuzz targets. right? But in many ways, yeah, they're kind of the same. I mean, of course, there are subtle differences depending on the context, but yes, I would say the short answer is yes.
Harnesses are also commonly used, I guess.
Which name?
Fuzz harnesses.
Right, exactly. Fuzz harness, absolutely. Test harness, you know. So I don't want to eat actually, perhaps we shouldn't, you know, I should take like more questions offline since we should have the coffee break now, right?
Yes, but if you want, if there are more questions, but otherwise, I think we.
So I can take more, you know, I'll have coffee.
Okay, let's thank Cristian again.
Just go through half my talk.
Sorry about that, but
No, don't.
sure.